Hi everyone, welcome to a new video of QMB. Today we'll be solving this Panther IceFun problem. This is to make a linear optimization and all that we have to do. Well, for this problem we have to start by the beginning reading it. That the Panther sells two snow ski models, Paw and Muscle. So then we read, okay, two models, a Paw and Muscle. Here we write it, Paw and Muscle. Okay. What else? The fabrication department has 12 skilled workers, each of whom works 7 hours per day. Okay. The finishing department has 3 workers who also work a 7-hour shift. Okay. So we have to look for our indexes, and this case is fabrication department, and linear no finishing department. Great. Then we keep reading. Each pair of post keys requires 3.5 labor hours in the fabricating department and 1 hour in finishing. Okay, and the muscle model requires 4 labor hours in fabricating and 1.5 in finishing. Okay, so we have that information. Let's repeat it. A PO is gonna be 3.5 in fabrication and 1 in finishing. Another one is 4 in fabrication and 1.5 in finishing. Panther IceFun makes a profit of 50 on the PAW model and 65 on the muscle model. Okay, so this is gonna be also part of our indexes that is net profit. It's gonna be a net profit. For PAW is 50 and for muscle is 65. Okay, we have this. I think the company wants to determine how many of each model produced daily to maximize the profit. Okay, so our decision variable is gonna be number of units produced, rate, and we need a total profit. So the company anticipates selling at least twice as many muscle models as PAW models. Okay, this is gonna be an important data we have to remember. Let's copy this. I like this. Oh, okay. Great. Now, let's continue. So, total profit is basically it's gonna be these numbers of unit produced times yes, and exactly the same for the next one. And as this is objective function, we have to maximize the profit. And this is gonna be the total profit. So it's gonna be some. Oh, sorry. It's gonna be some these two values. Amazing. So what are gonna be our constraints? We see that each department has their hours of daily operation is the muscle required for. Okay, they have the first constraint is gonna be as we read on the problem. Total fabrication department hours daily. This constraint is hours of fabrication available. You know, I think 40. Okay, fabrication available, and then the same but for the finishing department. Total. I'll change it to finishing. As we read on the problem that it was it meant to be, the same is fabrication, finishing, available. And the other thing that do you guys remember that I told you was important is that anticipate at least twice as many muscle models as paw models. That is something we have twice the capable group, twice as many muscle models as paw models. Okay, those are gonna be our constraints. I'm gonna write the number of muscle models here. Models. Okay. So let's start from the beginning. Hours of fabrication available. It's gonna be. Let's see. Fabrication is here it says 12 skilled workers, each of whom works 7 hours per day. So it's gonna be 12 times 7, that in this case is 84. Then the other department is 3 workers, 7-hour shifts. That this is gonna be 7 times 3, 21. For fabrication hours daily. And for these two, we have to do something called some product. That is not something from other world. We just have to do is select some product, these values, number of units to produce. No, wait, I'm doing it reverse. That is the fabrication. Well, it doesn't matter if you do it in any of these ways, but I want to do it this way. And the other some product is the same, but using these values is a finishing department and units to produce. Nice. So for this, these values can't exceed. Wait a second. Okay. These values from here can exceed these 84 hours. You can't work more hours than is available. So we have to put the following on this. And as is the same, we have to put the symbol. Okay, there we have it. Our first constraint. And for the other one, it has to be twice as it is. Muscles is gonna be twice as paw. So we graph paw, and we have do this. For this one, we write muscle because it is muscle that has to be twice as small. And for the function, we don't put even, we put. Okay, we have all set to go and use the solver to make our lives better. Here we put data solver. Its first set objective is gonna be okay. Sorry. Okay. My computers sometimes get slow. It's gonna be here total profit. We have to maximize, so it's max by changing the variable cells, which are these ones, and let's add our constraints. As these are the same, we graph this array Let's look that the sample is the same and the constraints are gonna be the following. Add, then let's add this one, change this one, and put it here. Add, and the last one that is just in case it's good to put it, is to make this value an integer. Okay, we have everything. Remember to change this to simple LP because we're doing it like that. And let's go. Solve. And here we go. We have the solution for a problem that is number of units to produce. For paw is going to be 3 and muscle 12. And the total profit maximized is going to be a paw with 150, 100, muscle with 780, and the total is gonna be 930. As easy as it looks, it is not such a deal. The only thing that kind of complicates in these problems is to look the inputs, the constraints, and everything. But don't worry, with practice you get it everything. Thank you very much, and hope you enjoyed this video. Subscribe.